Okay, let's take a look at the notes for Chapter 2, Section 1. This should be relatively short. Should look very, very familiar. These are properties that you've used, just probably not put a name to, or never really thought about the name that was associated with them. They're just basic ideas and definitions. We're going to start with the definition of an equation. And the definition of an equation is just a sentence that expresses the equality of two algebraic expressions. So I might have, for example, 3x plus 5 is equal to 5x minus 7. So that's an equation. There's a difference between an equation and an expression. Remember, an expression won't have an equal sign. That would just be like 3x plus 5. And it wouldn't have an equal sign. And the way we solve those when there are fractions are a little different. That's why we make that distinction. So that's an equation. A solution, or the root, would be any number that satisfies the equation. So if we look at this equation, for example, we would get 2x is equal to 12, so x is equal to 6, and 6 would be our solution. There are other problems that we've looked at. For example, the absolute value of x plus 3 is equal to 6, for example, and that gives us x plus 3 equals 6, so x is equal to 3. It also gives us minus x minus 3 is equal to 6, so negative x is equal to 9, so x is equal to negative 9. So in this case, we get two solutions, and we want to write that in set notation. Remember from Chapter 1, we talked about set notation, so this should be that x is equal to the set minus 9 and 3. So if you have just one solution, you can write x equals. If you have more than one solution, then you should actually write that in set notation, because it is the solution set, or the set of all solutions, that satisfies the equation. You might hear me refer to the solution as the root. When I talk about it as the root and the solution, I'm thinking about the graph and where that solution would be in the graph. For example, if you're solving for x, we're going to be talking about that's where it crosses the x-axis. Now, when you solve equations, and you've been doing this since Algebra 1, there are certain properties that you use. I'm not sure you remember the names of them. You probably do. You did a lot of proofs in geometry. So you probably remember some of these, but you use these properties a lot. I'm just going to give them a name now. And those properties of equality would be the addition property of equality. And that just says if I add the same number to both sides of an equation, I don't actually change the result. So if I have that A is equal to B, when I add C to both sides, I actually haven't changed that equation. A is still equal to B. So for example, if I have x is equal to 5, and I have x then is x plus 2 is equal to 5 plus 2, I still actually have that x is equal to 5. So I can add the same number to both sides, subtract the same number from both sides, and I have the same equation. The next is the multiplication property of equality, and that is multiplying both sides by the same number will not change that result. So for example, if I have 2x is equal to 10, and I multiply both sides by 1/2, I'm still going to get that x is equal to 5. So if I have A is equal to B, then A plus, or A times, sorry, that's multiplication, A times C is equal to B times C. Next is equivalent equations. Equivalent equations are equations that have the same solution set. So for example, if I had x plus y is equal to 3, and I had 2x plus 2y is equal to 6, or 4x plus 4y is equal to 12. Those are equivalent equations. So the solution set to each of those is the same. Okay, the solution set for each of those is the same. They're equivalent equations. Equations involving factors, or fractions, not factors, fractions. Equations involving fractions. When you see the equal sign, you can actually multiply every term in that equation by the least common denominator and cancel out those fractions. Don't do that with an expression, because then you've altered the expression. But with an equation, you can. So when I look at this particular equation, if I multiply each term by 6, and I know some of you don't need this, but it might help some of you, so I'm going to write it all out. I'm going to multiply each term, so x over 2 times 6 minus 1/3 times 6 equals x over 3 times 6 plus 5 over 6 times 6. So when I look at each of these individual terms, I can actually reduce this and eliminate the fractions, because 6 divided by 2 is 3. That's going to give me 3x. 6 divided by 3 is 2, so I have a 2. Again, 6 divided by 3 is 2. And finally, 6 divided by 6 cancels, and that makes this a 5. So I can solve it, because it's a lot simpler at this point, by subtracting 2x from both sides, adding 2 to both sides, and I will get that x is equal to 7. And that's the solution. If I substitute 7, that would make that fractional equation true. Okay. We have a few different types of equations. One is an identity equation, and that's an equation that is satisfied by every number for which both sides are defined. So that's an equation for which both sides are defined for x. That might look something like x divided by x plus 1 is equal to 1 plus 1 for every value of x. So whatever value I choose for x, this will be true. And that's an identity equation, that this would be true no matter what I substitute in for x. The next is a conditional equation, and that's an equation that is satisfied by at least one number, but is not an identity. Put a by in there. By at least one number, but is not an identity. So you might have something like 2x plus 1 is equal to 7. So 2x is equal to 6, so x is equal to 3. So that's a conditional equation. An inconsistent equation is an equation whose solution set is empty. Whose solution set is empty. For example, if I have 2x plus 3y is equal to 6, and then I have 2x plus 3y is equal to 10. And that should give me parallel lines. Remember, parallel lines have no solution, so the solution set is the empty set, and that would be inconsistent. When you're solving an inconsistent system, you might see something like x is equal to x plus 2. So when you solve this, you get 0 is equal to 2. We know 0 is not equal to 2, so therefore that makes no sense, and therefore it's not a solution. Now there's a difference between an inconsistent equation and an identity. So let's look at those two. An identity may look like this. I might have 8 minus 3 times x minus 5 plus 7 is equal to 3 minus x minus 5 minus 2 times x minus 11. So when I solve this, I have 8 minus 3x plus 15 plus 7 equals 3 minus x plus 5 minus 2x plus 22. Combining like terms, I get 3x plus 30 is equal to, oh, that's a negative 3x, negative 3x plus 30. So what that is an identity, because you can see if I would add 3x to both sides and subtract 30 from both sides, I'm going to end up with 0 equals 0. And that's an identity. Okay? If it's inconsistent, it might look like something like this. 5 minus 3 times x minus 6 equals 4 times x minus 9 minus 7x. So I have 5 minus 3x plus 18 is equal to 4x minus 36 minus 7x here. So I end up with minus 3x plus 23 is equal to minus 3x minus 36. Clearly, when I add 3x to both sides, I'm going to end up with 23 equals negative 36, which really doesn't make any sense again. We know they're not equal. Therefore, it's an inconsistent equation, and it has no solution set. They're probably parallel. If we were graphing in the coordinate plane, they would be parallel. Okay, the next we're going to look at linear equations in one variable. A linear equation in one variable x is an equation of the form ax plus b equals 0, where a and b are real numbers. A is not equal to 0, because if a was equal to 0, ax would be 0, and it would just be a line. Strategy for solving a linear equation: if fractions are present, so if you have a fraction, multiply each side by the least common denominator to eliminate those fractions. Use the distributive property to remove any parentheses, combine like terms. Use the addition property of equality to get all variables on one side and all numbers on the other side. Use the multiplication property of equality to get a single variable on one side. Check by replacing the variable in the original equation to make sure that your solution is correct. Okay, so the first one's pretty easy. We'll take a look at that. I'm going to add 5 to both sides, pretty easy. and I have minus 3x is equal to 18 divided by negative 3, and I get x is equal to negative 6. When I look at the second one, I have some fractions and I have some integers, and what I would do to simplify this is I would add 2 to both sides and kind of simplify that, so I have 1/2 x minus 2 is equal to 1/3 x. And then, at this point, you can multiply by the least common denominator, which would be 6. So I have 1/2 x times 6 minus 2 times 6 equals 1/3 x times 6. So 1/2 of 6 is 3, so I get 3x minus 12 is equal to 1/3 of 6 is 2x. I can subtract the 3x from both sides, and I have minus 12 is equal to minus x. So in this case, x is equal to 12. That's the answer for that one. Let's take a look at a few more of these. Number 3, my least common denominator is 6. When I multiply y minus 7 over 2 by 6, minus 1/3 times 6 equals y minus 7 over 3. Now there's a lot of detail. I'm writing a lot of detail. You don't have to write that much detail, but I'm putting it down so everyone can see what I'm actually doing. Now I want to be careful here and make sure I have parentheses around those numerators, because when I take 6 divided by 2, I'm going to get 3, and I want to make sure I distribute that across the y and the 7. And the same is true on this side. I want to make sure that I distribute that across the y and the 7. Okay, so in that case, I'm going to get 3y, nowhere to write, 3y minus 21 equals, oh, that's a minus, sorry, that's a minus, minus 2 equals 2y minus 14. So 3y minus 23 is equal to 2y minus 14. So y is equal to 9 in this case. Not much room, but there it is. Next one, I'm going to multiply each term by 8. Oh no, by 4. I don't have to go to 8, just 4. So again, when I multiply that x minus 2 over 2 by 4, I want to put that in parentheses. And I also want to put this x minus 3 in parentheses. There's a subtraction sign there that's really important to us. Okay, so now this reduces to 2. So I have x minus 2 times 2. When I multiply this, I cancel those 4's and I have negative, and in parentheses, x minus 3, because it's important that I distribute that negative sign across those parentheses. Those 4's will cancel. This will become 7. I will get 2x minus 4 minus x plus 3 equals 7. So x minus 1 equals 7. So x equals 8. And that's the answer for 4. Let's take a look at just one more of the last two so I can let you go. Let's do number 5. Okay, my least common denominator will be 6. So I will have x minus 1 over 2 times 6 minus 3x minus 4 over 6 times 6 equals 1/3 times 6. This will reduce to 3, which will give me 3 times x minus 1. these will cancel, so I'll use the distributive property on the first one, but I'll have to distribute this negative sign inside those parentheses. And then this will reduce to 2. So this will give me 3x minus 3 minus 3x plus 4 is equal to 2. They cancel. I get 1 is equal to 2. And guess what? That is no solution, or the empty set. Okay, the homework we're going to do in class. Remember, we have books in class, but if you want to bring your own, that's fine. And I will see you Monday. Have a nice weekend.